Corresponding parts of congruent triangles are congruent. CPCTC. The definition of congruent triangles is regularly expressed in the following way. Corresponding parts of congruent triangles are congruent, or simply CPCTC. In the reasons column in two-column proofs, the definition of congruent triangles can be stated in three ways. Here are examples of the three ways. So we have triangle ABC is congruent to triangle PQR, which is given. Line segment AB is congruent with line segment PQ because that's the definition of congruent triangles. Angle ABC is congruent to angle PQR because corresponding angles of congruent triangles are congruent. And we also have line segment AC is congruent to line segment PR because CPCTC. If two or more triangles are congruent by one of the congruence postulates or theorems, SSS, SAS, ASA, AAS, or HL, then all of their corresponding parts are also congruent. In a proof, you may be asked to prove a pair of angles or sides congruent. To complete the proof, you may need to prove two triangles congruent first, and then conclude the angles or sides in questions are congruent by CPCTC. In effect, the proof will be one step longer than the proofs we've been practicing all along. Here's a three-step proof from earlier in this unit. Compare this to the next slide to see CPCTC in action. Alright, so given that AB equals DE and AC equals DF, and angle A is congruent to angle D, prove that the triangles are congruent. So we begin with our given information. Then we see that those segments are congruent to one another. Therefore, due to the SAS postulate, the triangles are congruent. Alright, so this proof is one step longer than the previous proof with CPCTC as the final reason. So the final step is not to prove that the triangles are congruent. That's the third step. The final step is to use that to show that these third sides here are congruent to each other. So we begin with our same given information. Therefore, these segments are congruent to each other. Therefore, the triangles are congruent. Therefore, these third sides here are congruent to each other because of CPCTC. Here's a five-step proof from earlier in this unit. Compare this to the next slide to see CPCTC in action. Given that AF equals GB and AK equals BK, and this triangle here is equilateral, prove that these triangles here are congruent to each other. So we start with our given information about the segments. Therefore, the segments are congruent to each other. We have the triangle GFK here is equilateral. Therefore, this side is congruent to this side because that's the definition of an equilateral triangle. Therefore, because of side-side-side postulate, this triangle is congruent to this triangle. This proof is one step longer than the previous proof with CPCTC as the final reason. So instead of stopping after you prove that the triangles are congruent, we go one step further and prove that this angle is congruent to this angle. So we do all of the same steps. We do prove that the triangles are congruent with the SSS postulate, and then knowing that they're congruent, we can then show that angle A is congruent to angle B because corresponding parts of congruent triangles are congruent. Here is a two-column proof puzzle. Alright, so given this information, let's see what it is. AB is parallel to GF, AB is parallel to GF, AC is parallel to HF, so AC here is parallel to HF, and we see that CG is congruent to BH. Alright, so given the parallel lines, we can see that certain angles are going to be congruent because alternate interior angles are congruent. So which angles? These ones. Angle ABC, ABC is congruent to FGH, FGH, because here's some alternate interior angles. And we also see that angle ACB, ACB, there, is congruent to angle FHG here because those are also alternate interior angles. So then let's move on to our second piece of given information. CG is congruent to BH, and that is given as well. Therefore, the triangles are congruent because of ASA. So we have angle, side, angle, angle, side, angle. And because those triangles are congruent, we can conclude that AC here is congruent to HF because corresponding parts of congruent triangles are congruent.